open and closed intervals. So open and closed intervals look a little more difficult than they are. All you need is a quick explanation. What you see on the left side of your screen is the worksheet filled out from page 285 of your guided notebook that came bundled with your access code. So before I address that, as I address that, I'm going to talk about some actual numbers. So say we have solved a problem and we got an answer that looks like that top thing, a less than x less than b. What they are saying is they got an answer like 2 is less than x is less than 5. So this is saying that x is anywhere between 2 and 5, but because this less than symbol does not have an equal to line on it, like that, the 2 is not included in the answer. 2.1 is, and 2.5 is, but 2 itself is not included because there is no little equal to line right there. So I'll take that back off. So an open interval, it gives you like the boundaries of the answers, but the numbers you see are not included in the answer. So an open interval, as you see here, is when we use parentheses to give that answer. So our answer would start, reading our number line from left to right, start at 2 and go to 5. So an open interval is related to the arrows without the line under them. Your closed interval, I will use the same numbers. Notice that now there is an equal to symbol along with the inequality. That means my boundary includes the number I see here and here. So my answer does have 2 in it, as well as 2.1, 2.3, and so on. So this equal to line is the same as a bracket here. The bracket means the 2 is part of the answer. It's not just the boundary of where the answers start. Same with that 5 there. Half open interval, these are two separate examples. A half open interval means that one side of the section of work is included as an answer and the other side is simply the boundary line. So if I had 2 is less than or equal to x, which is less than 5, on this side I have the equal to, so 2 is included in the answer. But on this side of the x, I don't have an equal to, so though 5 is my boundary, it is not included in the answer. Same with that one, they've just moved the things around. In this case, it is 2 is less than x is less than or equal to 5. So this time 2 does not get included, it's simply the boundary, and then 5 does get included. So an equal to line goes with the bracket, a less than or greater than line without the equal to goes with the parenthesis. Open interval, if x is greater than 2. That means, again, 2 is not in the answer. It's just the boundary line of where my answers start. So if I'm reading a number line from left to right, this is where my answer starts. The number immediately after 2. This arrow is pointing, if I look at it as an arrow, to the right. So this boundary is going to then go on forever to the large side of the number line. This is an infinity symbol. Infinity goes on forever. It is not a number that we can include. It is an idea of numbers that keep going. So infinities are always a parenthesis. Okay, x is less than b. We've been calling b 5 for all these examples, so this looks like this. Whereas this number line from 2 to infinity started at 2 and the arrow was pointing that way. This number line starts in the negative direction. Notice my inequality arrow is pointing back toward the negative side of the number line. So the infinity is on the negative end. So it's going to start in the negative infinity direction. Infinities are always parentheses. There's no way to include an idea. We would be including actual numbers. So negative infinity is an open parenthesis. And then this list of answers stops. 5 is my boundary line. There's no equal to sign. So 5 is not included, but 4.9999 is. And that graph, as you can see, would look like if I have a number line. 5. I'm going to change color because it's getting crowded in there. So it'd be right here. But I'm shading all the way back to negative infinity, going on forever. All right, a half open interval. So half open intervals, as you can see in our example, one side is included and the other side isn't. My copy of this paper has their examples switched around. So when we get here to shading, I'm going to move these. I think that they have fixed yours since this printing where they gave me my copy. So if I have something like x is greater than or equal to 2, the equal is included. So now I have a bracket that starts at 2. 2 is part of my answer, and it's going on forever. That arrow's pointing that way, so I'm going to shade that way to the positive infinity. I said I'd move over here. See, they have a B there, but the example that goes with what we just did on my paper is down there. So this line should have the bracket facing positive infinity and shading forever. Now for our example, it starts at 2 and goes on forever. Okay, so our last example here, we made B5, so x is less than or equal to 5. Again, 5 is now included because the equal to line. But my arrow is pointing to the negative side of the number line. So my graph will be at 5. See 0, 1, 2, 3, 4, 5. But it's facing the negative side of the number line and going on forever. As a side note, when I do these as my work, I actually do the graph and then I write the interval because the interval notation is based on the graph. Once you've drawn your graph, you simply read what you wrote from left to right. So the first thing I wrote was negative infinity going down the purple number line. The last thing I wrote, I stopped at 5. And it's a bracket. So without even having to think now, once I've done my graph, I know that infinities are always parentheses. It started at negative infinity and it stopped at 5 that has a bracket on it. I will include this handout, but down here you see the answers to these end up there. So the set of all real numbers between A and B is called an interval of real numbers. In an open interval, neither endpoint is included. In a closed interval, both endpoints are included. So open is parentheses, closed is brackets. In a half open, only one point is included. So it could be a parenthesis and a bracket, or a bracket and a parenthesis. Linear inequalities are inequalities that relate to linear expressions. A solution to an inequality is any number or list of numbers that gives you a true sentence when substituted for a variable. So as I said, I'll include this handout. I hope that works. I hope that helps you. Let me know if you have any questions.